hard stop at 6 p.m. I know I said the same last time and didn't work for me, but I'll try to make it uh, uh, 6 p.m. and just 1 hour this time around. So so a few things that I wanted to cover today. So I'm sharing my screen. You should be able to see it. So we are number 40, meeting number 43. It's been a lot of meetings. Uh, just the regular stuff. First of all, we'll just go over quickly over the agenda. We'll have some C++ quiz. I'll talk about the book of the month, kind of a half self-promotion because I was involved in this book. Update on my blog post. This should be post. I remember fixing it. I don't know what happened. Not blog post, but blog post regarding stud set. Duplicated code in const and non-const members. How we used to do that, if we used to do that, and how we should use it in the future. Uh, should be very interesting to see how this kind of feature is evolving. As usual, I'm looking for people to have a topic and speak. It doesn't need to be full 1 hour. It can be anywhere from lightning talk to anything that you would like to present. Anything that you've seen during your daily work, code reviews, anything. Well, actually, the one with the const and non-const function is something that I've seen the past couple of weeks in a code review. I decided to kind of share it with you in terms of like best practices and how things can be done. Um, so the idea here, if you're new to this meeting, so who's new to the meeting? Anyone? So everyone is been here before. Okay, perfect. So, but oh yeah, there is someone actually raising. Hey, Mark. So the idea here is really to exchange ideas and just promote more than C++. And I'm just the conduit, the vessel to just present stuff. But the idea is to have discussions and exchange ideas and things like that. So so feel free to participate. It's not basically just me speaking here. I'm just presenting ideas and I want to hear other people thoughts and how they think they can do things other like differently. So yeah, feel free to participate. It is sponsored by Qualcomm wireless department, which I'm part of. Specifically, thank you for Charles Bergen, which is a big supporter of this meetup. Uh, we have a Dropbox link where I place this specific set of slides. We have a Slack channel which I'm not really using. We have Discord. Ask me for a link because the link is keep changing. People do ask me for a link through the Meetup page. So if you need the link, just let me know. I'll send you the link for joining the channel. Uploading the meetings to SDCPP Meetup YouTube channel in case you wanna go over something that we discussed. I'm maintaining the handles SDCPP Meetup, and I have my own Twitter handle also, Kobe_CA. So I'm maintaining both of them. Feel free to follow. Practical Modern C++ by Martin. I actually have an update to something that I posted some time back, which I'll talk about it in a few minutes when we hit that. But before that, C++ quiz again. If you have any questions about anything, just stop me and ask anything that you, or if you want to make a comment or anything like that. Okay, so what I'm gonna do is I'm gonna swap to the first one, and I don't know if I'm gonna have all five because I do wanna be on the 6 p.m. Mark. So Okay. So that would be the first question. So what is the output of this program according to the C++ 17 standard? We have a static int a and we print it.
I think there's some guarantee that the value is 0, but I don't know with the optimizations levels. I think like O3 and all, I think all bets are off.
It is 0.
Okay.
It is by definition is 0. If it wasn't, by the way, just to let you know, if it wasn't static, it is an undefined behavior. We can't really touch it if it's not initialized. So I don't know if it says something here about if it's not static. No. By the way, C++ 11, just remember, this is also guaranteed to be thread safe. I don't know if it says here as well.
So it says thread storage duration. So that means thread local storage. Is that what that's referring to?
Where, Brian? Which one? Which
It
part?
says or thread storage durations, section 6.7.2. In the standard,
Yes.
if constant.
Yes.
So that's thread local. They're saying. Right?
Yes.
I didn't know
Yes.
that.
Exactly.
Okay.
Exactly. That's thread local. Also guaranteed to 0 initialize. Yes.
Cool.
Correct.
Okay.
Yes. Yes. Okay. So we have that. Next one. Okay, according to C++ 17, what is the output of this program? Let me see. So I is 1. Then we should print 1, then plus plus. So it's 2. So I is less than 2, so we should continue. So we print 2.
I think it says while false, so I think you'll just get out of the.
Yeah, I
Maybe
can't
not,
remember
maybe
with
not,
the
But
while
maybe
does
not.
continue
history.
go back to the top without evaluating the condition for a do while? I'm not sure.
I think it should evaluate the condition.
Yeah,
regardless.
I think you're right. I think it is evaluating the condition.
Yeah, I think it should evaluate. Sort
Yeah.
of out.
Yeah.
So maybe just 1.
Okay, let me see. Maybe only 1. Yeah. So yeah, so the continue statement calls control to pass the loop into function to small causing the end of the loop, not to the beginning. That's the confusing.
That's what I was thinking at first, but then I thought maybe it's a trick question. It's not.
Yeah, it is a trick question. But the idea, okay, the idea behind it says difficulty is 1. The idea behind this question is at least we learn something new. So continue basically not to the end of the loop, not to the beginning, which is basically evaluating this one. Okay, next should be 1. Okay, I think we might have touched something similar here. So what is 1.0? This is all overloaded, right? By the way, I realized that Carbon doesn't have an overloaded feature, which is interesting.
D.
I don't know if they're gonna add that in the future, but doesn't
It's
have
going to
it.
print D.
DY?
1.0 is literal is like
It's
double.
double. Yeah, right. What do we do if we want an F?
That's going to be float.
Yeah.
Listed F, yeah.
Yeah, we just add F literal here, and it's gonna be float. Yes. Okay. So I think we're gonna be able to finish all 5. Okay. Difficulty is 2 again, C++ 17. So we have, oh, this is nice actually. Okay, so we have size of array, returning size of array, which is this one. Then size of array, which is this one. See, there's a lot of things that I wouldn't unpack in this question. And then size of array, which is this one. And then we have a size of array. We have an int of array of 10 elements. So 10 integers.
0, 0, 1.
Okay, so y0 here, y0 here, and y0 and y1 here. Why?
The
Let's start
first
with the
two-
first one. Why is 0 here?
That's the pointer.
It's a pointer. So what happens when we pass an array to this kind of function?
When you
What-
pass a pointer to the first element of the array.
Yeah, it's just a decay to pointer, right? So what's the difference between these two?
They are essentially the same.
Nothing. It's
The
syntactic sugar.
Yeah, it's just one of the things. By the way, there is a good book named it's from Packet. It's relatively new, like a couple of years back. Something C, like Experience C or Expert C, or something that has a lot of good C related stuff. So I remember when I was reading the chapter regarding this, there was some chapter regarding this part. They said that this is a good habit if you want to say I'm actually expecting, because the idea behind there is no, we lose information, right? When we take an array and we pass that, we don't know if it's an integer,
A single
or
integer.
yeah, a single integer, or it's just an array, right? We lose this information. This is why span and similar is really good to use. So but the book was saying that this is a good hint that I'm actually expecting an array. Obviously, I don't know the size of the array, which is kind of bummer. There was another syntax which I remember trying it, but it wasn't like, you can say here, you can have static and a number, like static 7, and you say, okay, I need at least 7 elements, and the compiler should do its best, not always it's possible, to verify that you're actually passing at least 7 elements. I don't know if anyone have seen that syntax in the
Are you talking about
wild.
like I've seen that in a static assert.
C. It's a
but
C. No, not static assert. It's a C. It's a C syntax. But I haven't seen it in production code, or I just saw it in the book. Let me see. Yeah, here I found something. I don't know if I don't know if you are familiar with that, but so this is the syntax. Static 7. And must be at least 7 elements. I remember it was 2 years ago when I was looking at this book again. I'll find the name and I'll post it. I tried it and it didn't really work. I don't know. It didn't seem solid.
Does this preclude passing a dynamically allocated array because it can't?
That's the
be
problem, right?
checked?
Yeah,
Yeah.
it cannot. No, you can. I tried dynamic and I tried like smaller than 7. It just didn't complain.
Okay.
Maybe things got better in the past couple of years because I haven't tried it. I remember literally trying it at the beginning of COVID. So that's almost 3 years actually, right? Yeah, it's almost 3 years, 2.5 years. Like just FYI, if you just happened. Okay, so let's finish that. So this is different, right? This is basically where we pass a reference to the array, and we can. And this is a C++ syntax. Okay, thanks. So this is a C++ syntax. It's a reference to the array, and we're not losing any information. And I don't think you can pass a different number. Like if this was a different number from here, I don't think it would work because the type of the array is it's int bracket 10. So whoever said 001 was right. And there is a nice explanation here. Okay. And the last one. let's take one at a time. So C1 would be what?
Before constructor one.
Yeah, it's a constructor. That's easy. Okay.
Yeah,
There is no distractor here, so we don't need to deal. Some questions are related to lifetime. There is no distraction lifetime here. It's not a question about distraction. So there is a copy constructor and there is assignment operator.
One,
Copy assignment, right?
Yeah,
So what people say 1,
2.
2. Why 2? Why not 3? It's a very common mistake, by the way, thinking that operator assignment operator is actually kicking here, not the copy one.
Because C2 has not been initialized before?
Yeah, it's just a creation of it. It's not if you just ignore let's say we have C2 and then C2 equals C1 in another line, then you have an instance and you assign another instance to this instance. So yes. And what I wanted to just refresh memory, though I hear that a lot of people already familiar with that, is the following. Give me a second. I'll swap to the other part of the slide. So you see this direct initialization? So CPP reference obviously has a lot of good information. So direct initialization is
You're
this one.
sharing the PPT. I think you're sharing the wrong screen. Okay, now it's.
Oh, okay. Okay, so let me share. You see this.
We're not seeing presentation mode. Now we are.
Oh, okay. Yeah. So let me know if it's still not showing correctly. So there is direct initialization and there is copy initialization. Okay, so direct initialization is what we had in this. Actually, we didn't have. We had just a copy. We had just a default constructor, and then we had copy initialization. That is usually mistakenly thought as using assignment operator, which is not. This is copy initializing object from another object, and there's this equal sign here that is sometimes confusing people. But I've seen that. I'm hearing that people actually understand how it's working. So this is the direct initialization. Okay. Book of the month. So it's actually kind of half self-promotion. I worked with Dorothy Kirk for about started April 2021. There is a story behind it. So the first edition was kind of written in non-modern C++, and I suggested to fix it, and they like Dorothy approached me, said that can you be the technical reviewer, and I agreed. So I'm the technical reviewer of this book. I think it's an excellent book. I think Dorothy did a great job explaining. It's a book of like 500 and something. So I have it here. I got it for free from Packet because being a technical reviewer. So I think it's a great book talking about object-oriented, but it doesn't make any assumptions that you know C++. It actually starts really from the beginning of like explaining a lot of the basic building blocks of C++ before going to the more advanced topics of object-oriented. So object-oriented it's still there, didn't die or anything. So I do recommend looking at this book. I think it's done very well, and my job was to help Dorothy to modernize the code inside the book to be modern C++. Just examples would be using const expr whenever is possible, using explicit constructor when appropriate, and const functions, and then we went into shared pointers and things like that. I do want to make a comment that in the beginning, we decided that we're gonna use let's say raw new and delete because there was too much to explain for newcomers about what is make unique, what is make shared, what is a template, because we're talking about template later. This is one of the issues in teaching C++, especially teaching new engineers that didn't, new software engineers that didn't actually, that came from a different language, from C or other languages, because there's a lot of things that if you want to teach using the new memory allocation idioms, have more idiomatic C++ memory allocation. You need to explain what is templates, what are these angle brackets, and so on and so forth. And Dorothy didn't want to confuse people immediately about that. So there might be some elements that are less modern in the beginning, but towards the end, we bring up and say, okay, remember we did this allocation with raw, new, and delete. Here's a better way to manage your memory without explicitly calling new and delete with using RAII. So there is a chapter on RAII and so on and so forth. I try to kind of summarize what is actually what you can find in this book. There's a lot of things that you can find in this book. It's actually very, very comprehensive in my opinion. She starts with C++ syntax, like the building blocks, basic I/O, talking about I/O streams, talking about control structures, user-defined types. What is type def? Why using is kind of a better approach in the modern C++ area, and enums, strongly typed enums, namespaces, const and const expr. This is, by the way, is targeting C++ 17. There is no there is no concept, and this is going to be a whole different book to kind of improve the syntax with, let's say, concept when you're talking about templates. Talking about functions, default value and functions. What I talked about, pointers, dynamically allocated memory using references as parameters is another option. She talks about class, inheritance, object-oriented concept, from single inheritance to multiple inheritance, all the problem with multiple inheritance. What does it mean when you have inheritance and you have multiple inheritance? What are the trade-offs between dynamic polymorphism and static polymorphism with templates? The difference between association, aggregation, and composition. Talking about exceptions, friends, overloading of functions. She has at least a couple chapters, as I remember, talking about STL, testing, how to do proper testing, few chapters about design patterns with all kinds of in categories. And then there are a few chapters regarding enhancing your code using modern C++, smart pointers, RAI, auto, ranges for loop, and so on and so forth. There's a lot of exercise for each chapter. So again, highly recommend picking up the book. I'm not getting any money, by the way, from that. So, but it is, I think, a good book. Dorothy is really, really passionate about her work, and she really likes object oriented. And I think it's a very good updated book that is very useful. Okay. So the next part for this for the agenda is an update on one of my blog posts. Again, so the both post. Remember fixing it, but I don't know. Regarding stud set. So just a recap, if you want to read the blog post, it's on Martin website under Kobe, and the blog post talks about something that I've seen in some product long time ago about a map, a stud map that had an integer and a struct, and the idea was to basically have an ordered. They use stud map. They want to have an ordered like log n of lookup and so on and so forth. But the ID was beside being used in the key of the stud map, it was also part of the struct itself. So you can see here an example. I just copy paste kind of screenshot from the blog post. So you can see that the ID was just part of it. So in reality, the object was much bigger than just an ID and a name. So you can imagine that there, and I don't remember if the ID was an int or maybe uint 64, but it was at least an integer. And what I was saying in this blog post, it's kind of redundant because you encode this ID in two different locations. The whole idea was to have the instances of the object ordered in a specific way by ID in a container. So long story short, what I presented is why not using stud set and just teach the compiler how to order this object by providing IDs. Now, the problem that I had back then is that, and I'm not showing the kind of the middle part of the blog post, but what I was showing is that you can basically have the stud set instantiated with a compare function, and the compare function teaching the compiler how to do a less than between two objects, and then you save an integer. Instead of having a stud pair with an int and an object, you have just a stud set of the object, and you save an integer 4 bytes for each entry, which can be significant. But I had one issue that I couldn't think about a solution back then, and the issue is that how can I create a class that has an explicit object constructor, but I can do something like find. So I have this set with a compare. I want to have a my set dot find and a number. I wanted this number to be used as the ID, and I had two approaches. One approach was, by the way, the compare function could be a lambda in unevaluated context, but it doesn't really matter for this specific item. What I had in the blog post is you can have two things. One option is I can have a constructor. I can add a constructor, even if I don't need. I can have a constructor that has a single parameter that takes an ID, and I'm not making the constructor explicit, so it's an implicit constructor. Implicit constructor, especially a single parameter constructor, is basically a conversion constructor. So the constructor, the compiler, if it sees 5 and I have a constructor that takes ID, and it's not explicit, basically it's implicit constructor, the compiler can take this 5, create a temporary, and do all the job for me in order to and find the object. But it's ugly. First of all, sometimes I don't need this constructor. First of all, it's an implicit constructor, so it would create temporaries and create conversions, and maybe I don't want that. Most of the time, I don't want that. So you can have an explicit, again, I'm not showing it here, but you can have an explicit constructor, but you need to wrap here in the dot find, you need to wrap it with explicit instantiation of a temporary and hand it off to the find function of the stud set, which that was a trade-off. It's also ugly. It's not very natural to kind of because I wanted to have something just like map. Stud map in the original code had this. It can have explicit constructor, and you can do that find 5, and everything works nice. But it didn't work well, and for some reason I kind of forgot about this whole heterogeneous lookup for containers. So, and I don't even remember how come I this month I ended up thinking about it. And so so just if you're not familiar with heterogeneous lookup, it's kind of a niche feature, but very important to optimize a specific path when dealing with such containers, either associative containers or binary trees containers or hash maps. So in C++ 14, we received heterogeneous lookup, and I'll explain what does it mean in a second, for what we call ordered containers. So stud map and stud set. In C++ 20, we received 2 more. Like we received support for heterogeneous heterogeneous lookup, also for unordered map and unordered set. So here I'm actually talking about stud set, but you can extrapolate that to the unordered containers as well. So the
Hey,
idea
Kobe,
behind
can I ask a question?
Sure.
I don't think I've come across this term heterogeneous lookup. Can you just explain like what does
Yes.
it mean and what's the special thing about it?
Yes. So heterogeneous lookup, and I have not here, but I have links. So since you are from Qualcomm, I know because we work together in the same company. So I actually provided a 1 hour or 45 minutes on heterogeneous lookup. So I can actually also provide you with the link, which is internal to us.
Sounds good. Yeah, that's good enough. Yep.
But no. But I do want to explain that. So when you have a stud set, just an example, but think about stud map and others the same. The default for comparing is studless, right? So if you look at if you go to CPP reference and you look at stud set, there are a few template parameters which are defaults. One of them is the compare function. You probably remember that. And usually we don't care because we want the studless to be the default one. We wanted to have the less than operator for our stud whatever set. So if I have 5, sorry, if I have an integer and I want to compare 5 to 7, if I insert 5 and then insert 7, the compiler knows how to compare 5 and 7. Now both of them are integers, so we good. What happens if I put in my own user-defined type? I need to teach the compiler how to actually compare these two instances of an object, and there are a few ways to teach the compiler how to do that. One is like the old way, actually a few old ways, but basically there are a few ways. One, you have studless is basically going to call a studless of, if there is one, of your object type. If there is one, good. Another way to do that, and then you can have a friend and you have a non-friend, you have a member, non-member, there are all kinds of variations, right? There is also, if you look online, there's also variation of specializing under the namespace std, under namespace stud, you can specialize studless for your own specific type. Not recommended. It's gonna work, but it's not recommended because there are other approaches which doesn't need, you don't need to kind of add stuff, specialization in this case, for in the namespace of std. So you can have your own operator or less than as part of the class or struct type. You can have your own functor that you can call it compare, and the functor takes 2 types of what you want to compare, and you can when you instantiate the stud set, you can pass the compare struct, just like I do here. So just ignore for non-heterogeneous feature, let's say C++ 11 and before, ignore this using statement. Just ignore it and just concentrate on this one, on this part, 18 to 20. Just ignore everything else. So long story short, if you don't want to have a operator less than as part of your struct type, you can have a compare struct with this operator paren, right? And the stud set internally, when it needs to compare, it knows that this is the compare function. Very, very easy. And inside we just compare integers. All good. We do want to have it const, by the way. It's very important. So this is the only way we can do that. We can't actually have other variations. Let's say I want to compare an integer to the object, or want to have a string to the object. I can't. But with this heterogeneous lookup feature, it's gonna be now. I'm just the messenger here. It looks like a hack, but I know. First of all, you need to have this using is transparent equal something. It doesn't mean the equal something doesn't really matter. You can have equal anything. We just need to have this is underscore transparent. This is a very important type inside the compare struct. Once we have it, we enable the feature of heterogeneous lookup where I can actually put all kinds of types to compare between my object, ID, maybe ID to ID. I can have all kinds of variations. So by using heterogeneous lookup feature, in this case, I can actually have an ID compared to an object. When I pass an ID, like this ID would be used to compare to find the object by traversing the tree, because I'm using a heterogeneous lookup struct because of this is underscore transparent. And again, this is underscore transparent is important. I don't know why it was picked this way, but it's very weird design, but it is what it is. Like for me, I just need to remember that this is what I need to do. I need to have this using statement to create this phony type, and this compare is heterogeneous. There is a blog post, at least one. Okay, Upsell has an FAQ that talks about heterogeneous. So if you go online, look at Upsell tip number, whatever, I can remember the tip number. I do remember it had the number 4 in it, but I don't know, don't quote me on that. CPP Stories has at least two blog posts about heterogeneous lookup. One talking about ordered map, like stud map, stud set. One talking about unordered, so stud unordered map, stud unordered set. And it has a lot of use cases, like comparing threads and because if you think about threads object, you can compare the ID, the POSIX ID. You can have all kinds of stuff to be used. So, but you need this heterogeneous ways to mix and match all kind of things in order to satisfy the comparison, not only object to object, but something else to something else, like anything you can think of that can fit into it would fit into it. So the interesting part, I remember when I was participating in one of the CPP and Beyond, like the first one, I think it was 2013 or something like that. And I remember, so it was a very small 60-something audience. I remember Scott Myers talking about it in one slide, and it just went over my head. I didn't realize how useful that could be. Because if you think about it, this is actually removing all the temporaries, removing all these things that I need to force a specific constructor explicit, removed, all that stuff goes away, but by having this nice feature. So long story short, if you are working in C++ 14 and above, and you have stud set or stud map, using stud set or stud map, and you find yourself lacking a specific comparison function that your regular stud less or the compare doesn't really work for all the use cases comparing two types of the object of the same object. So reach out to heterogeneous. When you're looking at C++ 20, when they added the unordered ones, there is also a hash map function that can be added. So they're a bit more, but it's very similar to what I'm showing here.
Toby,
And again,
question.
yeah.
Sorry, just on the using is transparent. Is that something that goes away in future C++ editions or versions?
I don't think so. This is
Okay.
a mandatory.
Okay,
This
so
is
that's
like
required for 14
yeah, it's
and
required. Like
above.
if you look at the bullet points, it says how to create a heterogeneous lookup compare struct. Number 1, create this using is underscore transparent equals something.
Okay.
So everyone using void because it doesn't. You can have equal int. It doesn't really matter. It just you need to have this nested type inside the compare. This is how actually stud set, for example, knows that this is actually a heterogeneous lookup capable compare struct because of the nested type.
Okay, got
Like
it.
this is the marker or whatever. Any other question related to this update? And you can read the update, by the way, the full update in Martin's blog post. Okay, so for the remaining 15 minutes, I think this is exactly 15 minutes. I'm going to talk about duplicated code in const and non-const members. You might be familiar with that. You might be already seeing that, especially Scott Meyer's book. Can't remember which one of the efficient or more efficient. It's a very old.
Effective, not efficient. Yeah.
Effective, sorry, right, effective and more effective, not efficient. Efficient is something else, by the way. There is efficiency plus it's a different book. It's a good book though. So the idea is common, but what I wanted to show towards the end of this part is how can we actually make it even easier to write and easier to remember. Okay, so I had a code review. I've seen that duplication. Same code in the const and non-const. And the idea is to minimize duplication. So how do you do that? So if you go online, just search for how do I remove code duplication between similar const and non-const, you'll get a few search results. This is just one of them. Okay. So I'm going to give you the recipe about how to do that, and then we'll talk about C++ 23.
Yeah, but you can have the non-const one call the const one, right?
Yes. So I'm going to show how, like, it's just a bit weird the way it's being done. So I'm going to show it, and then I'll show what C++ 23 has for us. Okay. So first of all, you start with implementing the common code in the const function. It's okay, and it is defined to elevate. Why? Because the non-const one would need to call the const one. So what we're gonna do, from the non-const function. First of all, maybe I should stop here and just make sure that everyone understand what is a const function, const member function that is. Okay, so const member function. If you have usually if you have const and non-const function, it is designed in the case that you're holding an instance of this class, and you want to call, and the instance is const, and you do that specific function, for example, that get. You want to provide an implementation that is const, so you mark the function as const. So basically, if you have a const instance and you try to invoke a function and the function is non-const, you get a compile error. Why? Because the instance, what we call this, is const. It needs to call a const function. So the good practice is, this is a good practice. I think there is no, I don't think the community has any disagreement. There is a disagreement about other stuff. Should we have no discard about everything? Should we have no except? This is always there are disagreement. But for const function, it's pretty much uniform and everyone thinks the same. If you have the opportunity to have const function, make it const. Then it allows us to, when we hold a const instance, for example, you pass a const reference to a function. Now you have a const instance. It's a reference, but it's a const instance. You can only invoke const function on this instance. Yes, you can const cast it, but don't do that. Okay, so this is why we have const function, and sometimes we have a const and a non-const variation, because sometimes we have a non-const instance and we want to invoke the same function, but in the non-const variation of it. So we can always take a const, sorry, we can always take a non-const and elevate it to the const instance. So we can always call from the non-const to the const one. So you want to implement the common code in the const function. Now here it's just one line, just make things short, but it can be a longer function. It's not okay to do the opposite. If you have a const object and you const cast it, sometimes, not always I think, but sometimes it would be a UB, an undefined behavior. So we try not to do that, unless we know for sure that we started off with a non-const. So let's see what we do. In the non-const function, so in the const function, we just have the implementation. In the non-const function, we start building this ugly Frankenstein casting. Okay. First of all, we need to elevate, in order to call the const function, we need to elevate the non-const part to be a const instance. So we take this. Now there are all kinds of variation on the books and all. Like you can have C pointer or C reference. It doesn't really matter. The important part is that if you have a reference, you dereference this. The important part is that you static cast it to const. Okay, so you take something which is non-const and you static cast it to const. We're not there yet. There is all kinds of these three dots on both ends. Let's see what we do. Then now you have an instance here that is a const. We can call the dot get function, which is now going to invoke the const function. Now, if you make a mistake and you're not casting to the const function, you're gonna call who? If it's a non-const function, what is this
Itself.
dot get?
Call yourself,
Recursively
recursive.
call
Gonna call
yourself.
itself. It's gonna be fun. Okay, don't do that. You need to have the const here. So you're gonna call the const function. Okay. But the problem is that if you remember, in many cases, not always, but in many cases, when we crafting this const function, we also returning maybe a const view to something internal. I'm not a big fan of get functions, but sometimes they are needed. But const functions usually would have a const view to something, usually a const reference, if not always. So this is not a const reference. It's a reference, but not const. So dot get would give me a const character. Now how do I take this const character to a non-const character? Now there is only one way to do that. At least one way that I know. We const cast it. Yeah, I know that I said that it's wrong to const cast, but remember, I start this whole this pointer was a non-const one. We are inside the non-const, so we are bound. The call is bound in compile time to a non-const instance. So we started off as a non-const. We elevated ourselves to a const. We call the function. Now we got to return type back. The return type is const. We need to cast it back. And again, it is defined because we started off as a non-const, so it is a non-const internally. We just did all kinds of games. Now, I first time noticed it in effective C++. This is the third edition, and this is, remember I told you there is, some people use pointer to the reference and have reference. That's what I used here. But you can have all kinds of variations. Some people, they don't like this long line, and I can understand that. So they have it in few lines just to make it more readable. This is fine. Oh, C++ 17 has this nice as const, which it kind of a better syntax. Instead of doing static cast to const, this as const is really nice. So you have this as const of this deref of this, then you call that f. Again, you have this const cast because we're getting a t reference, a t const reference. So we need to remove the const part.
Kobe, can I ask a
Yes.
question on this? What is the const cast actually doing? Is it verifying that the original identity of the object was non-const before?
Not
it does the
verifying
const cast?
anything. What it's doing, it's removing, it's casting off the const in compile time. Because
Okay.
there are rules about mixing const and non-const.
Okay, so it's just
Right?
getting bypassing those rules. Okay.
You basically say, okay, I have a const type in my hand, and I need to, let's say, assign it or bind it to a non-const.
Mhm.
That's not gonna work because if I have a const and I bind it to a non-const, let's say a reference of a non-const, now I can change it. But I started off as a
Right.
const. Now, if
Right.
I wanna modify this, I need to const cast it. Again, this is usually a code smell if you const cast. Const cast is one of the code smell, but reinterpret cast and all can be also code smell. But const cast is one of the kind of should be kind of alarming. But remember, we started off as a non-const, we elevated as const. So this is what I
Right.
like in the C++ 17. There is no, at least the static cast goes away, because before that we had two cast, static and const. We kind of hiding this cast, getting something as const. And there are other stuff, by the way, you can have all kinds of as mutable with all kinds of so this is another way you can have as const and then as mutable, and you have all this variation of as mutable. So one of the author here created this another way to make things a bit more nice, and this decal type auto would provide us the reference that we need. Okay, we cannot have just auto, we need the decal type auto. Okay, and let
So
me
how
see.
did I mean, as far as I know, and again, I didn't use a lot of this stuff, but I believe you can still modify mutables within a const method.
Oh yeah.
So
So
how did we handle it before C++ 17?
no. So what you're saying, let me know if you. So if you mark something as mutable, and one of the members is mutable, you can actually mutate it inside const, right?
Right.
But that was always there since C++ 98. So you
Okay,
can
so there's no
you,
conflict between the const
no
and non-const
conflict
in that case.
Yeah,
Okay, okay,
yeah,
okay,
yeah.
yeah, okay.
And it's used a lot. The one of the so lazy evaluation is one thing, like and there's all kinds, but one of the first examples for using mutable was you want to lock something, you have a mutex and you need to make it mutable because you want access, you want access, but it's a kind of a read-only function, but you still need mutable access to the mutex or to the lock with all kinds of with the POSIX API. So this is
Kobe?
one of the examples. Yes.
A good way to think about a const member function is not so much that it will not modify any internal state of the object, but that it will not change the externally visible state of the object.
Yeah, right.
So like you said, yeah, mutables can be used to take a mutex inside const functions.
Yeah, I agree. That's a better way to put it. Like the external observability of the class or the invariance is not changed. And there are a lot of examples about how this is actually being done. Thanks. Yeah, Martin, I agree. Okay, so there was another nice way to do the same with a helper function, which looks also nice, but all of these were kind of hacks that we had no choice. Let's talk about the future. So I realized that there is a better approach when I was attending CPP Con 2022, and Timur's had a great talk towards the end of the week of the conference, one of the noon sessions or before noon sessions about C++ 23. By the way, if you have a chance, a great speaker, great talk about 4 items in C++ 23 that are going to make a huge change. One of them is deducing this that I'm talking about, but there were also other stuff like MD span, format, and not result, but the error part, which I expected. So one of the things that I really liked, the first 20 minutes, he shows few slides about how like all the features of 23 divided. Like there was one slide about the language feature and 2 slides about library features, and then he start trimming them. Okay, this is less important for us. This is obvious, and this like tiny bug fixes, and then he ended up with just 4 main features in C++ 23. One of them was deducing this, which I think is going to change a lot of how we write code. Just like concept, by the way, change the way we write code. Though I realized recently that concept is just listening to ADSP is considered more as a better enable if versus what concept was initially was kind of we were expecting from. So I'll figure it out later and think about a way to present that. But here's the thing: there is a great blog post from Sai about C++ 23 deducing this. Lots of good examples. Highly recommend reading that. Talk about CRTP and other options. Tender has also a great one about deducing this. This is the paper. So we have Gasper, Sai, Ben, Dean, and Barry. And here's so I just copy paste motivation, and people inside Qualcomm, I had something very similar deducing this about talking about CRTP and others. So this talks about specifically how we can make things better in terms of this duplicate. So motivation, this is a screenshot from the paper. You can see that it says text block, operator bracket, and we have a const and a non-const. One of the most common usage of const and non-const, and there is the const function, and we static cast calling the position, the brackets with position, and then const cast it to, and then you can see that it says effective C++. So this is the original one, and this is the proposed one with deducing this. Now, deducing this, there's a lot of ways to write it. This is one way to have it. It looks a bit maybe strange because it's new syntax, but if you're coming from other languages that have self, for example, Python, Rust, and similar, it's very similar here. So self in this case it's a template, and it would be deduced to whatever it is. If it's a const, and this is self ref, so we have this forwarding reference. If it's a const, it's great. It's gonna deduce as const, and that's perfect. Otherwise, it's gonna be non-const, and it's gonna be binding to a non-const. So we have everything that we need just by having this deducing this. There is another syntax. So you know that in C++ 20 we have this auto. So just like you have auto in C++ 20, same deal here. You can have this auto ref self and forwarding reference, and all the code goes here, and it's being deduced in compile time. That's it. It's a duplicated code anyway, so why bother? Now, if you need to have all kinds of a special treatment, if it's a const or non-const, you can always have if const expr and query if this pointer is a const or non-const. You can always do that. So nothing is lost if you're asking yourself, but what if I need something a bit different? Can I have that? You can definitely mix and match. But I really like the fact that deducing this makes this whole thing shorter. There's so many use cases. The paper is relatively easy to read, most of it. Some cases are maybe a bit more advanced, but it provides you a good reference of how C++ 23 code would look like, especially with this. It also talks about the ref and ref not markers, but syntax that you can bind a specific function to an R value reference or an L value reference in compile time. Depends on how do you mark this function. Is it a ref or a ref? So this also goes away. This feature kind of goes away because if in C++ 23 you have deducing this, so you don't need that. This was my last slide. Yes.
I wish they had picked another keyword other than this. It seems it's awkward to see it in that position. Is it? For at least for me, it is anyway. It doesn't. Yeah.
Well, let me think. So self is the name of the parameter, and this is the actual. Yeah, I don't know.
I mean, the compiler must obviously knows what to do with it because of
in this
context.
In the context of the parameters, yes.
Yeah.
Yeah.
Because my brain doesn't know what to do with it yet, so I'll have to work on that.
How about is underscore transparent? Because of my brain, it took time for my brain to get used to that. I need to have this strange type just to be there to mark something for the library, for the standard library, that this is a heterogeneous compare struct. There's a lot of weird stuff happening, but
I'll get used to it.
Yeah, get used to it.
You can think of it as I can think of it as an implicit or explicitly stating the parameter that's always there implicitly.
Yes,
right?
Exactly. Yeah, it was always there. If you look at the paper, I think they say it was always there, but can we actually take advantage of the compiler knows what is this? Can we take advantage by using this knowledge with an explicit parameter? I bet that if Bjarne was thinking about passing it as a mandatory, just like Python is doing it in Rust. I believe. Yeah, but it's really hard. It was a long time ago. Lots of stuff were not really clear, like how. So I can understand that it's not. I don't know if back then there was any language that was passing the self type as one of the parameters. So I don't know. So I don't know if you could steal that idea from a different language. Today it's kind of common, at least now 3 languages that at least I'm aware of. So C++, Rust, and Python, they have this. It's obviously more complicated in languages like C++ versus Python. Python, there is no like R value, L value references. It's much simpler, but at least there is a self. Any other questions? Okay, we are 7 minutes after. I'll try to make it to be better next time. But it is better than the previous time. I think it was like 6:20. Okay, thanks everyone.
Thanks, Kobe.
Okay, have a good rest of your day. Bye bye.
Thank you, Kobe. Bye, guys.
Thank you, Kobe.
Bye everyone.